Just wanted to go over um, finding numbers of permutations when we repeat something. So for example, before, when we had three objects, A, B, C here, we figured out how many different possible ways we can reorder those. It's simply 3 factorial, right? So there's 6 different ways we can order those letters. But what if we repeat some of the letters? So in this case, we're going to spell mom, M-O-M. These two M's are interchangeable, right? They're indistinguishable from each other. So if it's M-O-M, that's the exact same thing as if I did M-O-M, right? So we've essentially, same deal. M-M-O is indistinguishable from M-M-O, and these two are indistinguishable. So we've essentially divided out the 2, right? We take the total number, which is 3 factorial, and we divide it by 2. As it turns out, it's actually 2 factorials, you'll see here in a second, because there's half as many now. We're down to just 3 possible options. And so this gives us our general form if we have n objects, but there's some that repeat a number of times, and some that repeat b number of times, and some that repeat c number of times, etc., etc. We can just take our n factorial, divide that by a factorial, b factorial, c factorial. It even holds up for one object, right? So if you divide by, we go back here, we only have 1 o, so if you divide by 1 factorial, dividing by 1 factorial, well, that's just dividing by 1. It doesn't do anything. So we can just ignore those. We'll do a few examples, and it should be really clear on these examples. How many different permutations are there of the letters in the word Arkansas? So we have 8 letters total, 1, 2, 3, 4, 5, 6, 7, 8. So our base is 8 factorial. But we have these repeats, right? The repeated letters. If I switch these 2 A's, it doesn't matter. If I switch this A with any one of these A's, it doesn't matter, right? I can reorder the 3 A's. So how many ways can I reorder the 3 A's? 1, 2, 3. Well, it's 3 factorial. So that's why I divide by 3 factorial. Also, I have 2 S's. There's an S here and an S here. So I could switch those back and forth, and that gives me another 2 factorial. So I divide out all those options, and I get this thing here. Zip code for Anchorage, Alaska, 99522. There are 5 digits. There are 2 9s and 2 2s. So therefore on top, I have my 5 factorial, and then I divide that by 2 factorial and 2 factorial, which you plug into a calculator, or you can do by hand. It's something. There you go. All right, we'll do a couple more here. I'll just give you these. This one's Mississippi. So same deal. We just want to rearrange it. How many letters are there total? 6, 7, is that 8? There's 11. 11 letters total, right? But there's a bunch of repeats. So there's an I here, and an I here, and an I here, and an I here. There's 4 I's. Let's see, 1, 2, 3, 4 S's. M-I-S-S-I-S-S-I-P-P-I. Okay, cool. So there's 4 I's, so we're going to divide by 4 factorial. There's 4 S's, so we divide by 4 factorial. And then there's 2 P's, so we divide by 2 factorial. Gives us a grand total of some. Go ahead and see if you can figure this one out. Pause. Hooray, you got 210. Good job. All right, we'll just leave it at that. The same thing can apply here to boy-girl arrangements, right? The boys and the girls are interchangeable with each other. If all we care about is their gender. So the same situation applies when they use those sorts of things. Okay, well, I'll leave it at that, though.